Hello, in this video we're going to be looking at a few things. We're going to be looking at angles, types of angles, and degrees, minutes, and seconds. And at the end we're going to try to apply these to some physical problems. Okay, so let's take a look at a line first. Okay, what exactly is the line? Well, we see that a line, it can be drawn through any two distinct points. Okay, so let's take a look at an example, what a line would look like. Okay, so say we have 2 points, any arbitrary points. So let's name this point A and this point B. Well, we can connect these 2 points through a straight line. Okay, and we can denote this in symbols by putting A, B, and drawing a line over it. So this is how we denote a line with symbols. Okay, and if we look right here, the portion of the line between A and B, including the endpoints A and B, that forms a line segment. So AB forms a line segment, and when symbols, we can just put this, but with no arrows indicating this is a line segment. Okay. Now, the portion of the line AB that starts at A and continues through B and past B is called the ray. And we can denote this in symbols also as well by drawing it like this. Okay, so here this denotes that A is the endpoint and it goes off in the other direction forever. So that's why. And here, this is, as we said, this one was a line segment. And this we call a ray. Okay. So with this in mind, let's go ahead and take a look at angles. And we're going to be using this idea. Okay. So an angle can be created by rotating a ray around its endpoint. The initial position of the ray is called the initial side. Okay, so let's go ahead and draw a ray. Okay, so we drew what we had before. We had this ray AB. Okay, so this is the initial side. Let me go ahead and put this in a different color. Okay, so we got this right here is our initial side of, okay, it's gonna be the initial side of our angle. Okay, and so we can form an angle by rotating this ray around its endpoint. Okay, so the initial position of the ray is called its initial side, and the ray in its position after we perform a rotation about this point is called, it's going to be called the terminal side. Okay, so this was our rotation. And now this was our terminal side. And the endpoint of the new angle formed is known as our vertex now. So this is our vertex. Okay. And by convention, these angles can be negative or positive. So let's see. So by convention, we're going to take a rotation of the initial side. When it goes counterclockwise, this is going to be a positive angle. So we see a counterclockwise rotation that's going to correspond to a positive measure of angle. And when we go clockwise, that's going to correspond to a negative degree measure of angle. Okay, so let's go ahead and take a look at what this is going to look like. Okay. Okay, so let's take a quick example of what a positive and a negative should look like real quick. Okay, so say if this was our terminal, our initial side of the ray, AB, and we want to rotate it clockwise. So we rotate it clockwise. This is going to correspond, like we said, to a negative measure. And if we went and chose to measure counterclockwise, we'll call this one A prime, B prime. And if we measure counterclockwise, it's going to be a positive measure of angle. Okay. Now, how do we name our angles? Okay. Let's see, so how to name angles. Okay. Well, there's a few ways we can do this by convention, okay? We can use the name of its vertex. Okay, so right here, this would be, we could name this angle A. So we could name this angle, be measure of angle A. We could call that, or just, since we're not talking about the measure, we could just put angle A. Okay. And likewise, we can also name with the 3 letters we created the angle with the vertex. Okay, so right here we can choose another point to label this, right? So we could just pick any point on our terminal side. So let's say this was C. So we could name that angle BAC, and this would be the same thing as angle CAB. And as we see, the vertex has to go in the middle by convention. Okay. So let's take a look at how we go about measuring these angles. Okay. So the most common use for measuring angles is radians and degrees. But here we're just going to be talking about the most common one. And the most common is to measure the angles in degrees. Okay. So let's take a look at measuring angles. Okay. So to use degrees, one complete rotation of a ray is assigned 360 degrees. And this is a measure of rotation. And here the terminal side corresponds to the initial side. And the example I'm about to show, the initial side corresponds to the terminal side. As we said, how one rotation is assigned 360 degrees. So say we have a ray AB, and if we go counterclockwise, we said this corresponds to 360 degrees. So let's go ahead and look at a few special angles. Okay, so we got 1 degree, and that's going to correspond to 1 over 360 of a rotation. And another example, we got 90 degrees. This corresponds to 90 over 360th. So that's 1/4 of a rotation. And we also have 180 degrees. And that corresponds to 180 over 360, which is half a rotation. Okay. So what would these look like? Let's draw a quick little drawing. Okay. So 1 degree is going to be, it's almost going to, so on this one here, the initial side's going to almost, it's going to be very hard. This is exaggerated, but it should hug it a little bit closer. It's pretty going to be pretty much coincide. Pretty much going to be close to being on top of each other. Okay, 90 degrees. We're going to have the initial side, and it's going to be rotated through 90 degrees, which is going to be perpendicular. So we could draw this little square right here. And 180 degrees, that's just going to look like a straight line right here. And that's going to correspond to the 180 degrees. Okay, so let's take a look at types of angles we have. So types of angles. Okay, we have acute angles. And acute angles are between 0 degrees and 90 degrees. And we also have what's known as a right angle, which is exactly 90 degrees. And another type of angle is a obtuse angle. And obtuse is between 90 degrees and 180 degrees. And we also have what's known as a straight angle. And that is exactly 180 degrees. Okay. Now another system used if we want to look at smaller divisions of a degree is something called the degrees, minutes, and seconds, which is sometimes abbreviated as DMS. Okay, so that'll allow us to look at smaller portions of a degree. Okay, so let's go ahead and look at our DMS, the DMS system, which is the degree, minutes, and seconds. Okay, so let's go ahead and first take a look at a minute. And by definition, we have 1 minute equals 1/60th of a degree. Okay, so we can put this in parentheses. That way we know we're talking about 1/60th of a degree. And they use this little apostrophe, or you could think of it as a prime. So 1 minute equals 1/60th of a degrees, and likewise 60 minutes equals 1 degree. Okay, so doing this, it allows us to look at smaller units of measures of angles. Okay, so let's go ahead and take a look at seconds now. So a second's going to be even smaller than a minute. Okay, so now we got seconds. And by definition, 1 second equals 1/60th of a minute. And this is 1 over 3600 degrees. Okay. And likewise, we also have 60 seconds equals 1 minute. Okay. So let's go ahead and take a look how this works in practice. Okay. So say we're given an angle measure using this convention of degrees, minutes, and seconds. Let's see how we could convert to degrees. Okay. So let's go ahead and take a look at an angle. Okay. So say we have 23 degrees, 24 minutes, and 7 seconds. Okay. So all this says is 23 degrees, 24 minutes, and 38 seconds. Okay. And we're going to round to the nearest thousandths of a degree at our final answer. Okay. So let's go ahead and write down again our conversions we're going to need for this problem. So we have 1 minute equals 1/60th of a degree, and we also have 1 second equals 1 over 3600 of a degree. Okay. So now we can go ahead and convert using what we have. Okay. So we're gonna go ahead and break this up. So we got 23 minutes. 23 degrees, 24 minutes, 7 seconds. This is equal to 23 degrees plus 24 minutes plus 7 seconds. Okay. So now we have 23 degrees plus 24, and we're using our conversion that we see that a minute is equal to 1/60th of a degree. So we can multiply by 1/60th of a degree plus 7 times, and here we see that 1 second is 1 over 3600. 1 over 36,000th of a degree. Okay. So what do we get? We get 23. Okay. Okay, so we get plus 4 over 60 degrees, 7 over 3600 degrees. So when we put this in and calculate, we get this rounded to the nearest thousandths is 23.402 degrees. Okay. So let's go ahead and take, if we want it to go backwards. So we can also do the same thing if we want to go backwards. So let's go ahead and take a look at another example. Okay. So say we have 57.241 degrees, and we want to convert this to, so we want to get degrees to the degrees, minutes, and seconds. Okay. So let's see how we can do this. Okay. So this is going to equal to 57 degrees plus 0.241 degrees. And let's rewrite our conversions we're going to need. So here we're going to have, we have 1 degree equals 60 minutes. Okay. So we're going to use that conversion, and we're also going to use the conversion that 1 minute equal to 60 seconds, which is equal seconds. Okay, so let's go ahead and plug this stuff in. See what we get. So we get 57 degrees plus 0.241, and we're just going to plug in our conversion. So 1 degree equals 60 minutes. Put the prime in there. Okay. So now when we plug that in, we get 57 degrees plus 14.46 minutes. Okay. So this, we're going to have to break it up. Okay. So now we get 57 degrees plus 14 minutes plus 0.46 minutes. Okay. So now we're going to have to go ahead and use our conversion to get this from minutes to seconds. Okay. So if we use that conversion, we're going to get 57 degrees plus 14 minutes plus 0.46, and we're going to plug in our conversion. 60 seconds. So this equals to 57 degrees plus 14 minutes plus 28 seconds. Okay. And if we use the degrees, minutes, seconds convention in way of writing, this is going to equal 57 degrees, 14 minutes, and 28 seconds. Okay. And likewise, we can also add and subtract. Using degrees, minutes, and seconds. So a quick example. Say we have 32 degrees and 42 minutes, and we want to add 28 degrees, 31 minutes. Okay, so when we add the minutes, we get 73 minutes, and when we add the degrees, we get 60 degrees. But we see we could break this up. 73 minutes is the same as what? 60 degrees plus, 73 minutes is the same as 60 minutes plus 13 minutes. And if we remember from our conversion, 60 minutes is the same as 1 degree, so we can go ahead and regroup these. So we see that 60 degrees plus 1 degree plus 13 minutes is equal to 61 degrees and 13 minutes. And we can also subtract. So let's see. If we have 32 degrees and we want to subtract off 5 degrees and 23 minutes. Okay, so let's see what we would get. So we get 31 degrees. Okay, here you see how this one has minutes and this one doesn't. So we're going to have to borrow from the degrees, and we're going to have to convert that to minutes. Okay, so remember that 1 degree equals 60 minutes. So this is going to be also have a 60 minutes, and we're going to subtract off 5 degrees and 23 minutes. Okay, so here what do we get? We get 26 degrees, 37 minutes. Okay, and now let's look at another similar example with borrowing. Okay, just to get a better feel for this. Okay, so let's say we have 60 degrees minus 10 degrees, 50 minutes, and 10 seconds. Okay, just like the previous example, we're going to have to borrow. Okay, so here we are going to have to rewrite this as what? 59 degrees and 60 minutes. Okay, here we're also subtracting something that has seconds, so we're going to have to regroup from this one. And as we remember from our conversion, that 1 minute equals 60 seconds, so we're going to make this to 59, and we're going to put 60, we're going to add 60 seconds to this right here. And now we can subtract. So we got minus 10 degrees, 50 minutes, and 10 seconds. So when we subtract this, we get 50 minutes, 9 degrees, and 49 degrees. So this is what we get in the DMS system. Okay. So let's go ahead and take a look at a few more things. Okay, let's go ahead and take a look at something about angles, a little bit more of angle terminology. Okay, so let's look at something called standard position. Okay, so this just means when the vertex, when it coincides with the origin and its initial side is along the positive x-axis. Okay. And the quadrant the angle lies in is determined by which its terminal side resides in. Okay. Well, let's take a look at what a coterminal angle is. Okay. So these are angles with the same initial side but have different amounts of rotation. And one complete revolution is 360 degrees, but continuing past 360 degrees produces an angle of greater rotation. Okay. So let's go ahead and take a look at this. So a coterminal angle would look like this. Okay, say this is our initial side, and we rotated it through, say this was 30 degrees. So if we went ahead and rotated this past 360 degrees, it still has the same terminal side and they coincide. So we see that 360 degrees plus 30 degrees equals 390 degrees. So we see that 390 degrees and 30 degrees, these are coterminal. Okay. So what this says is that any integer multiple of 360 degrees added to our initial angle will produce what's called coterminal angles. Okay, so let's go ahead and put this in writing for an example. Okay, so we see 330 degrees plus a rotation of 360 degrees produced 2 times. It's going to equal 30 degrees plus 720 degrees. So that's going to equal 750 degrees. So we see as this example that 30 degrees and 750 degrees are coterminal. So it would be just like this, except we go ahead and go through another rotation. Okay, so we get the result in general that the measure of an arbitrary angle plus 360 degrees times any integer multiple, that's going to equal a coterminal angle of an arbitrary angle. So let's go ahead and put this in writing. So we're going to get the measure of an arbitrary angle plus 360 degrees times any integer multiple. That's just going to produce a coterminal angle. Of any arbitrary angle. Okay. So let's go ahead and take a look at this in practice. Okay. So say we have a toy gyroscope. Take a look at a warp ball. You can apply to physics. And this toy is advertised to rotate at 13,000 RPM, which is revolutions per minute. through how many degrees will a point on the edge of the gyroscope move in 1 second? Okay, so let's go ahead and see what we get. So we have 13,000 revolutions per minute. And let's go ahead and convert this to degrees and seconds. Okay. And we're going to use the conversion that 1 minute is what? 60 seconds. And 360 degrees equals 1 revolution. So we see the revolutions will cancel and our minutes will cancel, and we're going to be left with degrees over seconds. And if we want to get how many degrees this will make, we're going to have to multiply by 1 second. So on this time, it's going to, so multiplying by 1 second, that's going to give us the number of degrees. So we would see in this example that this would rotate through 78,000 degrees. Okay. Now, if we want to use the concept of coterminal angles, let's go ahead and see what's the smallest possible, and we're going to choose positive coterminal angle. That 78,000 degrees applies to. Okay, so let's take the point that we're talking on the gyroscope, say it corresponds to 0 degrees, and in that 1 second it sweeps out 78,000 degrees. Okay, so what angle does this correspond to? Okay, so let's go ahead and see how we could do this. Okay, so we're going to just use this formula we had up here. So we're going to get the measure of the smallest coterminal angle. That's going to equal 360 degrees times our integer multiple, and that equals 78,000 degrees. Okay. So here we see that the measure of the smallest angle, positive angle, that's just going to equal 78,000 minus 360 degrees times the integer multiple. Okay, but here's how we're going to be able to solve it. Okay, so let's go ahead and take a look at what this has to be. Let's go ahead and take a look when this equals 0. So here we're going to get what? 78,000 minus 360 degrees times n equals 0. Okay, so here we're going to get 360, and if we move this 360 to the other side, we get 7,800, and if we divide by 360, we're going to see that this n is equal to 2.16.6 repeating sixes. Okay, but here this is an integer multiple, and if it's greater than this, it's become negative. So we want it positive, so we're going to choose the integer that's smaller than this. So we see n has to be 216 for this example. Okay, so let's go ahead and plug this in to see what our coterminal angle, the smallest positive coterminal angle, is going to be. So this right here is going to equal to 78,000 minus 360 degrees times 216. And when we plug this in, we see that this corresponds to a coterminal angle of 240. So we see from this example that 240 degrees and 78,000 degrees are coterminal angles. Okay, so let's go ahead and take a look at one more problem. Okay, so let's say we have this problem. The Earth rotates, and as a result, celestial objects in the sky appear to move across the sky from east to west. Someone observing celestial objects remains stationary on Earth. The objects will gradually move outside the field of view of the telescope. As a result, a motor can be attached to a telescope that will rotate at the same rate as the Earth. With this information, calculate how long it should take the device to turn through an angle of 1 minute in the direction perpendicular to the axis of the Earth. Okay, so let's go ahead and work this out together. But if you want, you can pause the video and you can work this out on your own. Okay, so let's go ahead and draw a picture. That way we can get an idea of what this is going to look like and make it easiest to solve. Okay, so let's go ahead and say we have the Earth. What is that going to look like? Okay, so let's try to draw a little bit bigger. Okay. So here's the axis of the Earth, and here's the Earth rotating. Okay, we could call this the equator, and or it could be anywhere on the Earth. Okay, let's say we're here on the Earth. Okay, so we want an axis perpendicular to the Earth. We want to choose to measure perpendicular to the axis of Earth. So this would be perpendicular. Okay, so we have a telescope on Earth. So let's say we have got a little tripod, and that's our telescope. Okay, and we want to see how long it should take the device to turn through an angle of 1 minute. So that's going to be really small, so this is going to be exaggerated. So let's see how long it should take to turn through this angle. Okay, and so let's go ahead and think about what conversions we used. Okay, what we could use for this problem. So let's remember that 1 minute equals 1/60th of a degree. So we're going to need this conversion. Okay, and we also got to know the angular speed that the Earth is rotating at. So the angular speed, this is the number of angles it traces out in time. So we know this is going to be it's tracing out 1 revolution in 24 hours. And we want to convert this from revolutions, we want to convert that to angles, and we know that 1 revolution is 360 degrees, and we're going to want to convert this hours to seconds. Okay, so let's go ahead and do that. So we see this is going to equal 1 revolutions in 24 hours. So we see 1 hour is equal to 3,600 seconds. And we also have, we want this in degrees, so that's going to be 360 degrees in 1 revolution. So we're going to get our revolutions canceling, and we're going to get our hours, so we're left with something in degrees over seconds. Okay, and let's take a look at what angular speed is. That's just what? The measure of angles over time. So this is the measure of rotation over time. Okay, so let's go ahead and plug in some of these numbers. Okay, so this is what our omega is right here. It's this right here. Okay, so we're going to go ahead and solve for the time it's going to take to go through an angle of 1 minute. Okay, so if we solve for time, we get that our time is just going to be the angle divided by our angular speed. Okay, so just plugging these in, we see that the time is going to equal 1/60th of a degree, and we're just going to divide by this number. So we get, so in the denominator we're going to have 360 degrees and over 86,400 seconds. So if we go ahead and divide, we're going to get 1/60th of a degree times 86,400 seconds over 360 degrees. Okay, so we see our degrees cancels, and if we go ahead and calculate this out, we see that it should take about 4 seconds. Okay, I hope you found this video useful, and if you like it, be sure to like and subscribe.